Hello everyone. Uh, Myself Vinny Jindal. I have done my graduation in electrical and electronics engineering, and I'm going to present the topic projectile. So, what is a projectile? Projectile is a parabolic motion, and in this we are going to discuss about the how the projection is being done. So, suppose this is a horizontal axis and this is a vertical axis. A body is being projected with a velocity u with angle of inclination theta. So the body will goes like an inverted parabola, like this. So this is a peak point, which is called H max, maximum height. And this is H. If we resolve the component of the velocity u, it is going to be u cos theta and u sin theta. This is the initial horizontal velocity, and this is initial vertical velocity. So we make an assumption that acceleration along the horizontal direction is zero. So being acceleration is zero, the horizontal velocity remains constant. The horizontal velocity remains constant throughout the motion. And the gravity is acting downwards. So because of the gravity, there is a change in the vertical velocity. Change in the vertical velocity. Suppose initially the vertical velocity is u cos u sin theta, its magnitude will continue to reduce like this. And when it reaches to the top of the height, the vertical velocity is zero. At maximum height, vertical velocity is zero. So the only component that is being there at the top of the height is horizontal velocity, which is u cos theta, which always remains constant. So this is the initial description about the projectile. Now we are going to derive few equations. We know the equation of uniform acceleration. Uniform acceleration. The first equation is v is equal to u plus at. V is the final velocity, u is the initial velocity, a is the acceleration, t is the time. S is equal to ut plus half at square. S is the displacement covered by the object. The third equation is v square minus u square is equal to 2as. This is the third equation. See, when the object goes from the point of projection to the maximum height, that time period is called time of ascent. It is going up. Time of ascent. When it is going down from maximum height to the ground again, this is called time of descent. So being projectile is a symmetrical one. So the time of ascent is equal to time of descent. Whatever the time it will take to reach to the top is equal to the time it will take to reach to the bottom of the ground. So there is a one thing which is called time of flight. Time of flight is a max. It is a total time during which object is in the air. This is the time of flight's capital T. Time of flight is equal to time of ascent plus time of descent. So as I already told you, the projectile is symmetrical. So time of ascent, time of flight is double of the time of ascent. Now, we will take the vertical motion first. V is equal to U plus AT. At top of the height, the vertical velocity is 0. Initial vertical velocity is U sine theta. And as it is going against the acceleration, because acceleration is acting downwards, but we are going upwards. So this is going to be minus G time of ascent. So time of ascent comes out to be equal to U sine theta divided by G. So according to this equation, time of flight is double of time of ascent, which is 2U sine theta divided by G. This is the expression of time of flight. Now, we are going to derive the maximum height. We know the equation S is equal to UT plus half AT square. S is being, again, we are going to take the vertical projection. So S is being replaced by H max. Initial vertical velocity is U sine theta. And if we take the instant at the maximum height, we will take the time as time of ascent minus half G TA square. Why there is a minus sign? Because the body, the object is going against the gravity. So H max is equal to U sine theta, time of ascent, which is U sine theta divided by G, minus half G, time of ascent, U sine theta divided by G whole square. We will simplify this mathematical equation. U square sine square theta G minus of G U square sine square theta over 2G square. So one of the G will get cancelled out. So this comes out to be U square sine square theta over G minus U square sine square theta divided by 2G. So to make the denominator equal, what we are going to do is, I will multiply and divide it by 2. So this is equal to 2G 2U square sine theta square minus U square sine square theta. The expression for the maximum height comes out to be equal to U square sine square theta divided by 2G. This is the expression of maximum height. Then the last thing we have to find in this one is range, horizontal range. Horizontal range is how much horizontal distance covered by the projectile. This has been denoted by capital I. So I'm again using the equation S is equal to UT plus half AT square, but now I'm using the horizontal direction. So horizontal distance covered is capital R. horizontal velocity is u cos theta, and when it covers the entire horizontal range, that means it will take the time which is equal to a time of flight, the time in which the object is in the air, which is capital T, and the acceleration horizontally is 0. So based upon this equation, r is equal to u cos theta, and the time is equal to, from this expression, is 2u sine theta divided by g. So it is equal to 2 u square cos theta sine theta divided by g. So we have a mathematical formula: sine 2 theta is equal to 2 sine theta cos theta. So range comes out to be equal to u square 2 sine theta, u square sine 2 theta divided by g. So this is the horizontal range of the angular projection. So this is all about the angular projection, the horizontal range, maximum height, and time of flight. So thank you very much and have a nice day. Thank you very much.